kilometers of forest in the Amazon, and they have a huge impact both with local scale, obviously, continental scale, and even on a global scale. On a local scale, the forest is affecting the temperature through the evaporation of water from leaves and land. It is critical in recycling water. It's estimated that the rainfall in the Amazon originates in the Atlantic Ocean, and it's estimated that every drop of water recycles 3 times as it crosses the continent, so that it rains, evaporates, rains a second time, evaporates, and rains a third time before it reaches the Andes. And that's absolutely critical. Without that transpiration and rainfall, we would not have this forest. The forest also provides wood to local community, wood exported to the world. The standing forest, the old-growth forest, is absorbing a large amount of carbon dioxide from the atmosphere every year, offsetting a good portion of the carbon dioxide that we're emitting through the burning of fossil fuels, which is a tremendous service to the entire globe. The hydrological cycle that I've already mentioned has also a global component. The Amazon exports water that feeds the agricultural heart of North America, the Great Plains of the United States, the wheat belt and corn belt of the United States is fed from water from the Amazon, and also Southern Africa. As dry as much of Southern Africa is, an awful lot of its water is exported from the Amazon basin up through clouds and rains down in Southern Africa. So the Amazon basin has an incredible role in the global hydrological cycle, in the global carbon cycle, and provides services for all of us. Now, what are the consequences of global warming going to be for tropical forests? We don't know. If you were to use the projections of the Intergovernmental Panel on Climate Change, made in 2007, we can expect temperatures in a very broad belt of about 40 degrees of latitude around the equator to increase by 3 to 4 degrees centigrade by the end of this century. This belt around the equator is already the hottest place on the planet. But when we increase the temperature by 3 to 4 degrees centigrade, we're going to be establishing novel climates that have no analog in the world today. We can't look out at the distribution of vegetation around the planet today to predict what's going to happen, because there are going to be these entirely new climates with temperatures, mean annual temperatures of 30, 31, 32, 33 degrees that don't exist today anywhere, an annual rainfall of 2 meters, 3 meters, and even 4 meters. I think we're going to have forest. I think there's going to be a vast change, though, in the species composition of the forest. Some of the tree species and animal species that do very well at modern temperatures are going to do less well as the temperature increases. Others that are very rare today might do considerably better as the temperature goes up. The changing climate is going to shift the competitive balance among the species, and we're going to see very large changes in species composition. I suspect there will still be forest in the Amazon. There's still going to be 2 and 3 meters of rainfall, and even though the temperatures are higher, that will support a closed canopy forests. The worst case scenario is encapsulated in the global climate change model that's run at the Hadley Meteorological Center in England. And that model is unique in that it has a connection between a warming planet and a strengthening of the El Niño Southern Oscillation cycle. And during strong El Niño events, rainfall is reduced over much of the Amazon. And if global warming gives us more and longer El Niño events, we could actually end up with a desertification of the Amazon basin and a huge release of carbon dioxide. There's roughly 7 to 8 years worth of fossil fuel burning by our species. That amount of carbon in biomass in the Amazon forest. So for several decades, if this were to happen, we'd have a tremendous additional release of carbon dioxide. But the Intergovernmental Panel on Climate Change considers 22 global climate models in their analyses, and the other 21 models do not have this connection between global warming and the El Niño Southern Oscillation. So if you happen to read about these worst-case scenarios, the authors have picked this one Hadley-centered global climate model as the model that generates the worst-case scenario. In the other 21 models, the Amazon remains forest. And perhaps it's legitimate to consider what might be the worst-case scenario.